This is a lecture from Open Tuition. To benefit from the lecture, you should download the free lecture notes from opentuition.com.
All right, let's carry on with the last of the lectures on linear programming. But remember where we're up to. We formulated the question, we set up the constraints, the objective. We've now solved it. The graphical approach, which, as I say, is all you can be asked. Make sure you can interpret the graph, you know the terminology, how we're approaching it, and importantly, make sure you can solve the simultaneous equations. You can solve the lines together to get the maximum contribution, the point at which we achieve maximum contribution. However, if you turn to the next page, paragraphs 3, sections 3 and 4, the first one talks about spare capacity or slack. And it says, using the information from example 1, so it's the same question, calculate the slack for each of the constraints. And all that means is, remember, our constraints, let's turn back to the question, here we are. Material, we'd 80 kilos available, but we don't have to use all 80. If it turns out that maximum contribution only involves using 60 kilos, we only buy 60, no problem. But all we mean by slack is the amount of any spare of the limited resource. Have we used it all? If we have, we haven't got any spare, there's no slack. If we've not used it all, then there is spare, there is slack. Well, remember, our maximum occurred at point B. And I should hardly need ask, and you can't answer me directly, obviously, but at point B, first of all, materials. Are we using all 80 kilos or aren't we? Well, if you've understood anything of what I said, you should know the answer immediately. Yes, we are using 80 kilos because our answer is on the materials line. And so I'll write it here rather than keep winding up and down. But for materials, dear, oh dear, materials, with 80 available, we're on the line, so we're using all 80. There is no spare material, there is no slack. What about labour? With 180 hours available, are we using all 180 at our optimum solution? Well, yes, we are. Point B is on the labour line. And so we're using all 180. There are no spare hours, there's no slack. Finally, what about the demand? The limit there was 10, but we made 10 E's. Are we making 10 E's? No, we're not. At point B, we're only making, what was it? 5 E's. And so we've got spare. There was 10 available, demand. We're only satisfying the 5 we're making. There is spare of 5 units. So that's all it is. It's easy. It could take slightly longer, you know, if we were at point C, for instance. I'm not going to read you the calculations because that's not our answer, but if C had been the answer, we're on the materials line, there'd be no slack on material. We're on the demand line, there's going to be no slack of demand. But point C would be below the labour line. We wouldn't be using all the labour. There are 180 hours available. If we knew, I showed you before, but I'm not going to rewrite it, but if we worked out how many E's and how many S's we were making at point C, we could find out how many hours of labour we were actually using. The difference between that and the 180 would be the slack. So I think that's easy enough. It should make sense. But one more thing. which is quite important, both in terms of definition and in terms of the actual arithmetic. The last bit of actual arithmetic. We're at point B, and at point B, materials. We are using all the materials because we're on the materials line. If we had more materials, I could make more units and make more contribution. But we can't, because the question told us we could only get 180 labour hours. Oh, sorry, I was talking about materials, wasn't it? We only get 80 kilos. However, surely in the real world, no resource is completely limited. You know, it says here we've only got 18 kilos of material available, but surely there are always ways of getting more. The only problem is, to get more, you'd probably have to pay a higher price. There are very few materials where you can't get more if you're prepared to pay for it. At normal prices, we can only get 80 kilos. But just suppose I told you we could get more material, but if we did, we'd have to pay a higher price. We don't know how much we're paying at the moment. We weren't told that it wasn't needed. Maybe we're paying $5 a kilo at the moment. And they tell us, you can get some more kilos if you want. But to buy extra kilos, maybe they'll cost $6 a kilo, $7 a kilo. And you could be asked to calculate how much extra would you be prepared to pay to get more material. Why would I pay any more? Because if I bought more, I could make more units and make more contribution. So if I can make more profit, I'm prepared to pay more to get the extra kilos. Well, that extra is called the shadow. Make space. The shadow price. The shadow price is defined as being the most extra we would be prepared to pay for one extra unit of a limited resource. I'll do it for materials. Let's do it for materials and see what happens. And then you have a go at the other two and check with me. At the moment, we're using, we're on the materials line, so we are using the 80 kilos that are available. If I now told you, suppose you had 81 kilos. Well, of course, the constraint becomes 2s plus 4e equals 81 kilos. And although we don't redraw the graph, what would happen, the materials line would move out very, very slightly. And so the maximum would still be at point B. But with extra materials, we could make slightly more chairs. And if we were paying normal price for it, we weren't paying any extra, we'd make more contribution. And so what we do, we don't redraw the graph, but we say, how much would the contribution be if instead of simply having 80 kilos of material, we had 81? And so what would happen? Point B would still be where materials line cross labour. The materials line would change. It was 2s plus 4e, It was limited to 80, but suppose we did have one extra unit of the resource, so 81 kilos. We look at these individually, so labour is unchanged. It's only material we're looking at. So labour would stay at 5s plus 6e is 180. And as you just saw when I did that little bit on the graph, if those were now the constraints, point B would change very slightly. The values in S and E would be a little bit different. So again, we solve them together. Same way as before, or as I said before, if you do it a different way, no problem. But to solve together, I'll multiply again the first equation by 2.5 all the way through. So 2.5 times 2 is 5s, 2.5 times 4 is 10e, 2.5 times 81 is 202.5. I'll subtract the second equation from the third. So 5s minus 5s is 0, 10 minus 6 is 4e, 202.5 minus 180 is 22.5. E therefore comes to 5.625, which is slightly different as I expected. Before it was 5, with more materials would make a few more, it's 5.625. Now what happens to S? If I put in the first equation, 2s plus, well, 4 times E, 4 times 5.625 is 22.5 equals 81. 2s equals therefore 81 minus 22.5. 58.5, and therefore S equals 58.5 over 2, 29.25. So the mix has changed very slightly, and it fits. Oh dear, sorry, I shouldn't be doing this. But if it does move out very slightly, you can see for yourself that B moves very slightly. It'll be more E's and less S's, which is what's happened. But as a result, what would happen to the total contribution? The new contribution, remember, was 6s plus 9e. Because this 1 extra kilo would let us change our production slightly, we'll now have a contribution of 6 times 29.25 plus 9 times 5.625, a total of I'm right, I get 226.125. What was it before? With our current limit, the old contribution, I hope I'm remembering correctly, was 225. And therefore, this new mix being having 1 extra kilo available, we'd get extra contribution of the difference, 226.125 minus 225, 1.125. Now, a few things to listen very carefully to. And wind back, check the arithmetic properly if you're at all unsure. But a couple of things. Firstly, and most importantly of all, we'll only make an extra $1.12.5 if the contributions stay at 6 and $9 per unit. And that would only be the case if we carried on paying the normal price for materials. You know, they'd worked out contributions for us, so I don't know what the normal price is. Maybe currently it's $5 a kilo. Well, if you carried on at $5 a kilo, an extra kilo would generate 1.125 extra contribution. But I said earlier, to get more, we're probably going to have to pay more than the current price. It might be currently $5. We might have to pay $6. And if you pay $1 more, you make $1 less contribution. And so importantly, that 1.125 I did write before, but that's not the price per kilo we'll pay. That is the most extra that we're prepared to pay. So if we were currently paying $5 a kilo, we're prepared to pay up to $6.12.5. If we can buy an extra kilo for less than that, we will end up with extra contribution. If an extra kilo costs more than that, it wouldn't be worth buying. So I hope that makes sense. The other thing is relatively minor, but some people get upset and say, ooh, how can we make 5.625 executive chairs? You know, how can you make 0.625 of a chair? Well, you can. Because appreciating is always the case in exam style questions. The question itself was talking about the production per week. We know how many kilos of material we've got a week. We know the maximum demand per week and so on. And so that solution, we're saying, oh, we make 5.625 chairs a week. Well, it's an average, you know. First week you make 5 and you part way through a 6th. In the next week you finish the 6th one and whatever. And so don't start rounding. Assume always they are effectively an average per week or per month, whatever it is. And therefore 5.625 is feasible, is possible. So that's the way we do it. We repeat our solving equations together with one extra unit of the limited resource we're looking at. The shadow price is the extra contribution that will be generated. And so, and let's do it for the others. For labour, what I really do suggest, if you've understood me, is that you pause the lecture and have a go yourself and then start the lecture going again and check you got it right. Okay, well, I'll assume that you've had a go at labour on your own and that you've now restarted the lecture. And so, oh, good heavens, check with me, labour. In the same sort of way, the option is still at point B, which is where materials line cross the labour line. But this time the materials line won't change. We only look at one factor at a time. So the materials line, 2s plus 4e, was limited to 80. The labour, it was 5s plus 6e. It was 180, but with one extra unit of labour, one extra hour of labour, that now becomes 181. Well, we've solved the equations twice now, so I'm not going to waste time on the third. I'll do it the same way as I was doing before. If I take the first equation and multiply by 2.5, 2.5 times 2s is 5s. 2.5 times 4e is 10e. 2.5 times 80 is 200. I'll subtract the second equation away from the third. So 5s minus 5s is 0. 10e minus 6e is 4e. 200 minus 181 is 19. E, therefore, 19 divided by 4, which I should be able to do in my head, but I won't risk it, is 4.75. It was 5 units, remember. It's now 4.75, it's changed slightly. And we can now substitute to get S. If I put it in the first equation, 2S plus 4E, so 4 times 4.75 is 19, is 80. 2S, therefore, is 80 minus 19 is 61. S is 30.5. And so, this time, if we have more labour, we're able to make slightly more S and slightly less E. What would happen to the total contribution? If costs remained unchanged, the contribution would be 6S plus 9E. So 6 times 30.5 plus 9 times 4.75. The total contribution would now be 225.75. And what was it before? I'm not going to wind all the way back. I'm sure I remembered it properly. The old contribution was 225. And so, getting 1 extra hour of labour, if we were paying the same price as currently, it would earn us an extra 75. We're prepared to pay up to an extra 75 cents to be able to get extra hours. The shadow price of labour the difference between the two, 75 cents. And you see, there is a logic to it again. Labour. I mean, labour is never surely completely limited. We were told we've only got 180 hours. That's how we did the original question. But of course, you can get more labour, but you're going to have to pay overtime. So, currently you may be paying them $5 an hour. I don't know. If you want more labour, you're going to have to pay more for it. If you still paid $5 an hour, you'd get 75 cents extra contribution. But if I've got to pay them an extra 50 cents an hour, it's worth it. I pay an extra 50 cents to generate 75 cents, it's worth it. But if I have to pay an extra $1 an hour to generate only 75, it wouldn't be worth it. Here, there were the 3 constraints, so it should be immediately obvious. But what about the demand for E? At the moment, the most we can sell is 10. Suppose, it's perhaps a bit unrealistic, but suppose that somewhere I can pay money to be able to sell 11. What's the most I'd be prepared to pay to be able to sell more? Well, the shadow cost for E, shadow price rather, would be 0. There's no, we've got slack at the moment. We're not using all the demand that's there anyway. Even if demand were 11, even if demand were 100, it wouldn't make any difference because we were limited by labour and materials. And so it's only those constraints where there's no slack, where you're using all that's available. It's only those constraints which will actually have a shadow price. Okay, well, I warned you in advance. It'll take a while to go through all that, but we've now done it all. So, if you're unsure, go back through the note, go back through the lecture, but otherwise, have a go at the practice tests that I mentioned before that are on the main, linked from the main paper P1 page.